Welcome, everybody. It's a real pleasure to be here. My name is Jessica Fonzo. I'm a professor here at SAIS at Johns Hopkins, as well as the School of Public Health over in Baltimore. This is an event co-hosted by SAIS and the ERE program, as well as the Alliance for a Healthier World over at the School of Public Health. And we're coming together on a topic that is serious. It's a massive challenge. The links of food and water and climate are very intricate. I think all of us have seen media headlines recently of Nebraska, the flooding in Nebraska, the flooding in Mozambique. These were tragic glimpses of a new era, an era of climate-related natural disasters. Climate change is and will impact the lives of everyone and will have serious ramifications on both water and food security globally. We obviously know that there's going to be some populations who are more severely impacted, vulnerable populations, but it is an issue that all of us will have to face. We'll talk today about water security and food security in the context of this changing climate. We know that there's immediate need for considerable investment in adaptation and mitigation actions towards climate-smart agriculture and water and food systems that are resilient to these climate-related shocks. So today's seminar will delve into those water and food insecurities that we're seeing in the midst of a changing climate and what we can do as a global community to adapt and mitigate. There's some reports that came out recently that are out on the table. David can talk about those, as well as Mark Rosegrant during the panel session. So I'm going to first introduce our two speakers. We have two short keynotes, and that we'll have just some quick clarifying questions following those two talks, and then we'll have a panel. So let me introduce our two speakers, and then I'll introduce the panel thereafter. So we first have Ben Zajac. He's an associate professor here at Johns Hopkins at the Department of Earth and Planetary Sciences. He does research on hydroclimatic variability across a range of spatial and temporal scales. His work includes fundamental atmospheric and hydrological processes, as well as applications to water resources, agriculture, energy, and human health. He works across many different areas of East Africa, South Asia, and Central Asia. And before that, he was a research associate at NASA's Goddard Space Flight Center. It's a real pleasure to have him here. We also, following him, we have Janet Ranganathan, who's the Vice President for Science and Research at the World Resources Institute. She has really been a leader in looking at implications of climate, future food sustainability, and diets. Maybe some of you have seen WRI's recent reports looking at sustainable food futures, sustainable diets. These reports are really important, impactful, and are shaping the agenda, particularly around diets and food systems in the face of climate. Janet's also vice chair of the series board of directors. She serves on different advisory boards like the Sustainable Development Solutions Network, the Rockefeller Foundation Bellagio Center, and the World Economic Council on the Future of Food Security and Agriculture. So we'll invite Ben up to the podium, and he will talk about water security, and then Janet will follow on food security. We'll have a couple of clarifying questions, a panel, a Q&A to engage all of you, and then the most important, wine and cheese. So we'll start us off with Ben. Thank you so much, Ben.
All right, thank you, Jess and Johannes and the rest of the team for inviting me to participate in this event. So I have 15 minutes to deal with water security in a changing climate. Suffice to say, this will not be comprehensive. But what I'd like to do is, first of all, give a little bit of background that's going to be weighted to my perspective, kind of as a climate scientist and a water scientist, and then give a few takeaways, I think, about the ways in which a changing climate influence our approach to water security. So I'm going to start off with a definition that is clearly the result of extensive committee work, and that they got every word into it, but I think it's a useful exercise. So this is from UN Water, and their definition of water security, first of all, begins with the idea that this is about what a population can do. Okay, so that's kind of obvious, it's about human populations, but I think it's important to put that up front, both because I'm now going to talk a lot about physical climate stuff, but this is ultimately about populations. Also, it points out that this is a multi-scale problem, right? The idea of water security for a population of a nation or of multiple nations in a transboundary context is very different from the water security of a population of a village or of a household. And so you have to really re-scope your definition to scale. Next point is that the UN has decided that this has to be done in the context of sustainable access. Maybe that's obvious, but what it means is that, according to this definition, you can't satisfy water security with unsustainable pumping or with anything else that's unsustainable, right? If you're secure, it's because you're sustainable. Pointing out also that they have quality in here, because quantity and quality are two key elements here. I'm not going to talk about quality in these 15 minutes, but sometimes that's actually the most crucial issue. And the point that we don't care about water just because it's water, right? And so satisfying our water security in a literal sense, you know, for drinking water, sanitation, and hygiene is a very small percentage of what we mean by water security. We're talking about water as a means to an ends, and keeping track of those ends is critical. Water security is an interesting one to my mind because as Jess was just framing the event in terms of flood events, right? So water is both friend and foe, and the water security definition therefore has two almost independent parts, like securing water when you need it and protecting yourself from water when you, in a form you don't want it. And so you have to think about both of those to be comprehensive in your water security plan. And finally, water is a resource that we inherently share with the natural world. We might think about other resources in terms of, you know, what humans need with some externalities, whereas water, I think it's very central from the beginning that part of the value of water is the ecosystem services. So you need to think about security in those contexts. So there's a long gloss on a long definition to get us started, but I think hopefully it'll be helpful to keep that in mind as we talk about how climate influences our approach to this. Okay, so this, you know, everyone's got their favorite IPCC figures, right? They're famous or infamous for information-dense presentation material. This is my favorite, and this is a version of my favorite, okay? And so why do I like this so much? So this is the version in the most recent report that you all probably heard about that came out a few months ago about the 1.5 degree warming. And what they're showing us here for both a 1.5 and 2 degree warming, what's the change in mean annual precipitation? Okay, it should be simple, right? Just average annual rainfall and snowfall. And the colors are fairly intuitive. You know, we expect to see some wetting in parts of the tropics and high latitudes and drying in the subtropics, including much of the Mediterranean and the Middle East, Southwest US, Australia. Okay. What I love about this figure, though, is not the colors, it's the cross-hatching, okay, because I'm a nerd. And so the cross-hatching is really important here, because what the cross-hatching means is that if there's cross-hatching, then at least 2/3 of global climate models used in IPCC reports agree on the sign of the change. Not the magnitude, the sign, okay? And if you are a person who lives in, like, the United States, South America, Africa, or South Asia, so if you're most of the population of the Earth, you're in a place where the models do not have any kind of consensus on the sign of precipitation change in the future. Okay? And I think that's important to keep in mind when we think about how we plan for water security under climate change. And there's a different version of the same figure, and now instead of looking at the mean annual precipitation, we're looking at the extremes. So don't worry about the mean of that definition, just think of it as heavy rainfall, okay? First point is a lot more blue on this chart because most of the world, for good physical reason, is expected to get more extreme precipitation when you warm the climate system. Okay. Also, a lot more cross-hatching, especially on the 2 degree version here. That's 1.5 and this is 2 degrees, because we're pretty certain about this. So as climate changes, you can expect your precipitation to become more variable, more extreme, and you expect a lot of uncertainty in terms of the long-term changes in the total amount of precipitation available to you. The complement to that, crossed with the fact that temperatures are warming, is that if you're getting your rainfall in shorter bursts and it's hotter, soil moisture anomalies, so there's now water security in the context of something like rain-fed agriculture, right? Soil moisture is going to dry over much of the world, even some places that are going to see more precipitation total, all right? So water security-wise, you could look at a map and say, oh, look, it looks like we might get more rain, but you're not necessarily going to have a wetter condition for your agriculture if it's gotten drier. So there's just a lot more red. This is from an earlier IPCC report, slightly different projection, but my main point is just lots of reds and yellows, okay? And so uncertainty, overall drying, and more extremes. Last kind of science background slide here. And so this is probably hard to read. It's definitely hard to read. But this is from a paper from Nature last year. So we can see changes in water that are occurring now from space. So this is data from NASA's Gravity Recovery and Climate Experiment. Water's really heavy, and so when water moves over long time scales, it changes Earth's gravitational field. NASA can measure that and then figure out where we have trends in water, okay? And so that's been done for a while, and we see, so Grace was up there for about 15 years or so. And so if it's blue, there's been an increase in water storage. If there's red, there's been a decrease, okay? But what I want to highlight here, even though you might not be able to see, is that the reds and purples are changes that we can attribute to climate, okay, to a climate change. And so at high latitudes, you see a lot of reds and purples, right? Melting glaciers and ice sheets, drying of parts of the Arctic and subarctic. And then you've got your yellows and oranges, which dominate a lot of the populated areas. Those are places where we can attribute this to human activity, but not climate change, right? So groundwater pumping, diversions, reservoirs, things like this. And then there's the natural variabilities, the green. And so if you cross natural variability with changing demographics, water use, human activities, with the climate trend, that's where you come out on how climate's going to influence our water security situation, right? You don't want to just think about the monotonic trend in climate. You want to think about it in context. Okay. So a few, proposed takeaways from how we think about this in a context of uncertainty and complexity. One point that I think is well supported by recent thinking is that if you're going to think about water security in the context of a changing climate, you need to think robustly. And I'm using robust in the sense of the robust decision-making framework that was first popularized by the RAND Corporation and is now used in a lot of resource planning. This idea that you aren't necessarily going to be trying to optimize your outcome, you're going to try to understand points of failure and design away from them. Okay? And so I'm going to give a quick example of some work that my former student, Julie Shortridge, led on this, just to make this a little more concrete. So here we are in Ethiopia, northwest Ethiopia, the Lake Tana Basin, headwaters of the Blue Nile. Okay? The basin itself is being managed in a coordinated manner by the Ethiopian government, and what we see here are lots of recently installed or planned, in the near future, irrigation hydropower plans. They're managing this basin in order to optimize for irrigation returns and hydropower while keeping in mind issues of fishing, navigation, and tourism because they've got a nice waterfall and environmental flows. Okay? So this is what the decision makers tell us they want to optimize for. And based on this, they've assessed, they've scaled, they've engineered their plan. Okay? However, they also know they're dealing with uncertainties, climate change being the leading one. Also in this region of high erosion rates, land degradation is a big deal for your water resources, and the fact that they don't really know what's happening right now. So there are data limitations in terms of what the current water situation is. All right, so in a robust decision-making approach, what you say is like, okay, we're not going to optimize the system for return. We're instead going to say, what are the potential failure scenarios, okay, under different development strategies, and then once we identify those, once we diagnose those failures, what are the conditions that led to the failure? All right, and can we reappraise our planning in light of that? And so here's a quick example of how this plays out. We take all of their design scenarios, run our fancy models, run 1,000 realizations of samples from historic climate and water, all right? Run that 1,000 times randomly, and in almost 1,000 out of 1,000 cases, their maximum development strategy works. They meet all their stated goals. Kudos to the engineers, they designed this to be a good system. Then we do exactly the same thing, run 1,000 simulations under uncertainty related to future precipitation, which in this region, our uncertainty range is minus 20% to up 35%. Uncertainty in temperature from moderate warming to an extreme warming, and changes in evaporation from the lake, okay, as well as some information on sedimentation. And we say, okay, of those 1,000 simulations, how many times do you fail? And we find is that you fail in irrigation 412 out of 1,000 times, you fail in hydropower 628 out of 1,000 times. Okay, so the system that is perfectly designed for current conditions has failure points, which we can then explain in terms of, well, you fail on your irrigation if your precipitation fails to increase more than 3% and your warming is more than 1.5 degrees, and your lake evaporation doesn't decline, which it is unlikely to decline, right? And for hydropower, you get failure scenarios if the lake evaporation increases at all, or if you've underestimated it in the past, or if precipitation declines by more than 5%. So what you now have is a sense of a system that's well designed for the current climate conditions. How do we change our approach to the water security of that system under a changing climate if we want to avoid certain failures? Okay, it doesn't give an answer, it gives a framework. Okay, so that's thinking robustly. Another, I think, theme that's coming out of adaptation in the water sector these days is this idea that you need to plan to be nimble, okay? So being nimble means you can jump, right? But planning to be nimble means putting yourself in a position that you can jump. And that can mean a lot of different things at different scales. But I'm going to give a couple examples. Here's one example of this work that maybe some people here are familiar with, popularized by the Red Cross Climate Center. Who's been doing excellent work on this forecast-based financing problem. Okay? And this applies to water as a hazard, like water as a flood, also to water as a lack of a resource, for example, a drought. Okay? And the idea here is that under a changing climate, you take a forecast. Now, a forecast is not a climate projection. A forecast is like a weather forecast or a seasonal outlook, like what's it going to be like over the next weeks to months. If that forecast is let's say floods, there's a pretty good risk of a flood coming, you then provide financing to people who are vulnerable such that they can prepare. And that financing can be used for pre-positioning supplies, it can be used for cash handouts, loans, aid, materials, anything that they might need, okay? And then you get that to them and so that they are ready when the storm comes. All right? There's no question that this is economically efficient. That's been demonstrated again and again. The problem is, how do you have the confidence in a forecast to create action, right? And then how do you get in place all of the institutions you need to make this functional? And that's, I think, a key issue. As we get greater variability, we need to have this kind of institutional mechanism to respond in an anticipatory way, in a nimble way, when disasters are on their way. Another way this plays, and this might come up later when we talk about food security today, is in terms of insurance, right? So this idea of index insurance is something that CGIAR and others have worked a lot on. Can you get smallholder agriculturalists insurance based on a water-related forecast, right? So how much rain is going to come. Or not a forecast, sorry, a water-related probability of risk. And so this has been rolled out in many countries. This example links to food security. Of course, it can be used for other kinds of water-related disasters and risks. And if you can do this, it's known to free up the farmers to be more nimble, right? To be able to make the kinds of decisions they need to be ready for what's coming if they're given the confidence of insurance. So getting insurance out as an adaptive method for water security, certainly at small scale and then scaling up to larger communities, could be really valuable. The last point on being nimble, to scale out something like a transboundary issue. So the Colorado River, a very well-known transboundary water challenge, right? So the Colorado River Compact from the 1920s divided the water between the upper Colorado River Basin and the lower Colorado River Basin. Mexico used to get some water out of this river, right? So it's transboundary in states and theoretically transboundary internationally. And so why has this been so challenging? Well, partly because the West has developed a lot, but also in part because they made a compact that's based on a hard distribution of a volume of water. All right, so the Colorado Compact says this is exactly how much water in billions of gallons the upper basin gets, the lower basin gets, and Mexico might get over time. And the problem is they did the compact back here. This one it was designed, and it came after a wet period of about 20 years. So the instrumental record was wetter than it's ever been since, and so you end up with a hard distribution of water resources based on flows that you never saw again. All right. So I think that the literature is pretty clear that this kind of treaty is a bad idea in general, right? But nevertheless, about 40% of all water treaties, transboundary water treaties from the 20th century had this kind of approach, right? And it's still kind of the default when you go into negotiation. That's what people are expecting, like how much water do I get? And if that's a bad idea under normal climate variability, it's a fiction under climate change, right? And so we need to be thinking about on the transboundary scale, you need more nimble treaties, more nimble agreements that allow partners to collaborate to reach a decided, an agreed upon set of ends rather than expecting some kind of volumetric distribution. Okay, last point, then I'll stop talking. Related to this idea that you don't want to be doing a transboundary treaty based on the volume of water, I think that it's also been very clear in recent thinking that water security viewed as a silo leads to securitization type of thinking, right? Like, how do I stockpile my rights to water, okay? Whereas if you can put water in context, if you can add dimensionality to the problem because you understand why you want the water, it provides many more opportunities for resource efficiencies. And so probably the one that's gotten the most attention is the food, energy, water nexus, which has gotten a lot of both press and funding in the last 10 years. The idea being, okay, we're seeing increasing stress on water, on food, on energy, but most of that stress has to do with the relationship between the three. If we add dimensionality to our water problem and understand that what we're trying to do is create food or trying to generate energy, then we can try to adjust in those other ways via efficiency, via trade, via all the other ways that we might be able to meet our needs with less reliable water supply. And just to feed into the next discussion of food, if you look at what is water actually used for, this withdrawals, not necessarily consumptive use, but withdrawals, globally almost 70% is for agriculture. But there are regions where a lot of it is locked up for energy, right? That's most of the thermoelectric cooling. So the water's returned, but usually at a lower water quality. And so understand the fact that the sum total of this bar, 0 to 100%, is going to become unreliable, more variable, and in some regions is going to shrink. But it's made up entirely of these constituent parts. And if you can think about your water security in terms of its constituent parts, then you're in a better position to think about water security in the context of an evolving climate. Thank you.
And maybe just a few quick, one or two clarifying questions?
On your last slide, were you talking about both surface water as well as underground water?
Yes, yeah, that includes both.
Any other clarifying questions for Ben? They're going to be on the panel, so you can think of more questions as we go along. Yeah? Okay, Janet.
But talk about water, maybe Thursday. So yeah, thank you very much, Jessica, for inviting me, and thank you very much to this school. You've provided many great and talented employees at the World Resources Institute. So keep producing these great people. So what I'm going to talk...
Janet, you need to get the microphone.
Okay,
Do
yep,
you want
so-
to have a handheld one? Would you prefer that?
I'll try and stay here. You should put a handcuff on me. Yeah, so thank you again. So what I'm going to do in my very short 15 minutes, I thought you meant short me, rather than short time, is talk about what I actually think is one of the largest challenges facing humanity, which is how do we feed the planet sustainably. I'm going to talk about 4 major constraints by which we have to solve that problem. I'm going to give you an overview of a menu of solutions, inverted commas, they're all contextual, focus on 2 or 3, and then talk about how those solutions, if implemented, will contribute to the climate change mitigation problem. Does that sound okay? So let's get going. So here's that challenge. I called it the Herculean challenge, but how can the world adequately feed 10 billion people by 2050 in a manner, and this is where the constraints come in, that serves economic development while reducing pressure, water, ecosystems, and climate. So it sounds not so bad, but it's a pretty difficult challenge. We're about 7 billion, like we were in 2010, so another 3 billion people. And we have this gap between calories that we produced, food calories in 2010 versus 2050. We need to actually increase food calories by 56%. It's not a distribution issue. It's not like we can just redistribute and we'll have enough. There's actually a shortfall. And even with 2010, we've still got 820 million people going to bed hungry. We have about 2.5 times that amount going to bed too full, either overweight or obese. So it's part of the challenge. But anyway, the first one on economic development. We have a lot of very poor people working in the food supply chain. So in fact, directly and indirectly, agriculture supports 28% of the population, employed population on this planet. But agriculture contributes about only 3% of global GDP. So you can do the maths. You've got a lot of quite poorly paid people in this sector. So whatever we're doing to close that 56% gap, which is our goal, it's about food security, correct? We have to also address this problem. We can't have, it's sort of ironic that some of the people that go to the majority of the people that go to bed hungry are in fact the people that actually produce food. I'm not going to dwell on this too much, but because Ben has talked about it, but you know, food and its production actually uses a lot of water, and it actually contaminates water too. I'm not going to talk about that too much, but you can see the statistics here. I think you used 69, 68, we're pretty close. It's good. But that's the first constraint. First constraint was about contributing to economic development. The second constraint is reducing its impact on water. It also has to adapt to this changing water context. And already 20% of cropland is in highly water-stressed areas. And if you looked at irrigated crops, it gets much worse. It's around 56%. The third thing agriculture needs to do is to stop expanding into the remaining natural ecosystems. Not just because we want those ecosystems to be nice and contain all of these, you know, diverse species, but because we need those regulating ecosystem services that those ecosystems provide to actually support and underpin agriculture. And we project, with some of the modeling that we've done, that actually with a business as usual agricultural production system, agriculture will expand by 593 million hectares between now and 2050, which is about 2 times the size of India. So that's another challenge that we have to do, is how do we actually increase food production by 56% while not expanding the agricultural footprint, land footprint. And I should say that half of the vegetated planet is actually used for food production, of which 2/3 of that is actually for livestock production specifically. And then the last constraint, if those 3 constraints weren't enough, agriculture needs to contribute to closing a significant greenhouse gas mitigation gap to stay within the Paris Climate Agreement. And what you see there in 2010 is agriculture's contribution of 12 gigatons out of 40, I think it's 48 for the whole economy. So it's about 24% of 1/4 of global greenhouse gas emissions. But if we go forward to 2050, under a business as usual scenario, that 12 goes up to 15, which you say is maybe not too much, but consider this, that here's the budget that we've agreed to under a 2-degree scenario. So I'm not even talking about a 1.5-degree scenario, I'm just talking about the 2-degree scenario. The whole globe has to get down to 21 gigatons, and for agriculture to do its fair share of reducing, it needs to get down to 4, because under a business as usual, it would consume 70% of the economy-wide GHG budget. So that's really problematic. And I don't think people quite sort of cotton the significance. You know, even at my own organization, we're all very focused on the other energy system, the industrial energy system, but there is this food energy system that is going to have a massive contribution to climate change unless we get a handle on it. And again, agriculture is also affected by climate change. I just pulled this one up, but there's a whole lot of specific examples. I put some data down. This is a little kind of infomercial for Resource Watch. It's one of our newest open data systems, but I'll just show you some of the things you can do on it. See if I can get it to work here. So I put up this data on global croplands across the planet. I'm just zooming into India here, which you could do if you're on the system. And now I'm going to turn that data. You can just see where we are in India, Afghanistan. I'm going to turn that layer off, and I'm going to switch on a water stress and cropland layer, which comes from Aqueduct, some of our water risk data at WRI. So you can sort of see that sort of lines up with some of that irrigated croplands is. I've turned that off now, and I've just looked at the water occurrence change between 1984 and 1999 and 2000, 2015. So those red areas are kind of very high-risk areas. And just for the fun of it here, I've just added some data now on conflict and protests. And if I actually panned out, which I can't do now because I'm not on live, you'll see that a lot of those conflicts and protests are aggregate, they're accumulating around some of these hot space areas. And I don't want to sort of imply that, correlation equals causation, but we are starting to see very interesting and disturbing patterns. So let's talk a little bit more about solutions. I've been talking about constraints and challenges. We spent the last 6.5 years working on this report called Creating a Sustainable Food Future. And we came at it in both directions. We looked at how we could actually close that 56% gap by both producing more food sustainably, but also reducing demand for it, which is the red line. And we called this menu of solutions. We actually have 22 of them that are both production related and consumption related. I don't have the time to go through all of them. Here is that menu. We call it a 5-course menu. So, I don't know, you see reduce growth and demand. Some examples there. Increase food production without expanding agricultural land. Protect and restore natural ecosystems. Increase fish supply. And then reduce greenhouse gas emissions from agricultural production. So those are it. I'm just going to go into a few of them. So one of them is about shifting diets. And you might not sort of think about shifting diets as a food security issue, let alone a water security or climate security issue, but it very much is. And when it comes to climate impacts, or water impacts for that matter, or land impacts, not all foods are equal. And here, I don't know if you can read it, that's beef. So that's the green is the land footprint for beef per unit of protein. And then you can see whether it's cropland or pasture land. So a very large part of that is actually pasture land. The fresh water consumption there, and then the greenhouse gas emissions, which largely track the land use as well. And then you can kind of look at some alternative sources of protein down here. This little line just divides meat-based protein and plant-based protein. So it isn't just what we put in our mouth, it's the type of food we put in there as well. And unfortunately, the trends aren't going well for us when it comes to meat consumption. Meat is expected to increase by 80%, meat consumption overall by 80%. And actually for ruminant meats, which was that one right at the end, which is the most land-intensive, greenhouse gas-intensive of all, it's around 88%. So I would say maybe at WRI, we're working on a number of strategies to try and shift diets. It's easier said than done, but we are actually making some promising inroads there. The second menu item is a controversial menu item. We've come under a lot of criticism for this menu item, but it's avoiding competition from bioenergy for both food crops and land. So just to give you an example of the scale of that, the corn crop in the United States, which is one of the largest harvests of crops on the planet, 40% of that goes to a corn ethanol. Another 40%, or just over 40%, goes for feedstock for animals, and probably only 10% is consumed directly. But any kind of use of biofuels, whether it's biomass or for creating ethanol, that uses dedicated land is in competition with food. So think about that land gap. It just exacerbates it. Another issue that I just thought I would highlight here, again, food security, climate security, and a water security issue, is that the fact of the matter that in globally 1 in 4 calories between field and fork are wasted. And this diagram just shows you for different regions where it's getting wasted in the sort of the value chain. So, what you find is more poorer countries, a lot of the loss is actually occurring in the production phase and maybe the handling, whereas in richer countries, a lot of it is sort of waste. It's happening after it's been purchased. So if we could put a dent in that, when you actually reduce food loss and waste, you save money, you reduce greenhouse gas emissions, you reduce water, you reduce land. It's a sort of win-win-win. I'm just going to sort of conclude by talking about going back to the whole menu now, the 5 courses, and look at the impact on the greenhouse gas or the climate change goal, because Jessica asked me to make the link between food and climate change. So again, this is the 2050 baseline for agriculture. And as I said, we've got to significantly shrink that because that's going to represent 70% of the economy-wide emissions budget otherwise. So we have to get down to here. So we have modeled these things here, and you can sort of look at the contributions of different scenarios under the reduced demand side there. And I'll just put up the next one. which is about increasing the production sustainably. And then you've got a small contribution there from fish, not a big deal there. And then some of the protection, the last one there. Sorry, those are production-related agricultural emissions there on that fourth one. So you can see there is no silver bullet. All of these are quite hard to do, and we can't just pick one or two. Of course, some are more relevant to some countries than others. You could think about the US. So obviously, you saw food waste is about 40% of food between field and fork. Competition for biofuels is a big one there. But actually, the US is pretty good at producing high yields, so that particular category doesn't relevant as much to them. So kind of that's it in a nutshell. I wish I had more time, but it just gives you some flavor of our work. Again, thank you for the time. Super clear or super?
Okay, we just introduced Giannis. So Giannis will moderate the panel. Giannis is the director of the Energy Resources and Environment Program at Johns Hopkins here at SAIS. He's also a professor, and he's the founding director of the Initiative for Sustainable Energy Policy. He did his PhD in political science from the University of Michigan, and then was at Columbia University for about 8 years. He's written 4 books. He's considered one of the world's top energy policy experts. And in his spare time, he works on his Hindi, which is not really something most people do in their spare time. But he will be moderating the panel, and we look forward to hearing the discussion.
Good evening, everyone, and welcome to this event also on behalf of the ERE program here at SAIS. I'm very glad to be here, though I do have to say all the work literally has been done by Jess, so my contribution to this event is pretty much what you're hearing right now. I'm very glad, though, to introduce our remaining panelists. So we've obviously already heard from of Ben and Janet's accomplishments. We also have Mark Rosgrant, who is a research fellow emeritus at the International Food Policy Research Institute's Director General's office. Prior to joining the office, he was the director of IFPRI's Environment and Production Technology Division. And Go Blue, he's a PhD in public policy from the University of Michigan. He has extensive experience in research and policy analysis in agriculture and economic development, the future of world food security. He's the author or editor of 12 books and over 100 refereed papers. He's won numerous awards. He's a fellow of the American Association of the Advancement of Science and a fellow of the Agricultural and Applied Economics Association. So thank you, Mark, for joining us. Please. We also have Paddy Lavera, who is the Food and Water Program Director for Food and Water Watch. She has a bachelor's degree in environmental science from Lehigh University and a master's degree in environmental policy from University of Michigan. Looks like we got a number of alumni here today. Before joining Food and Water Watch, she was the deputy director for the Energy and Environment Program at the Public Citizen and a researcher at the Center for Health, Environment and Justice. Food and Water Watch's food policy work includes fighting factory farms, food safety and meat inspection, and the need for antitrust policy to address growing consolidation in the food and agriculture system. So thank you, Paddy, for joining us. And last but not least, we have Dr. David Reitmiller, who serves as the director of the 4th National Climate Assessment with the U.S. Global Change Research Program. He's on detail from the Department of Interior's U.S. Geological Survey. And prior to joining the survey, David was the chief climate science and lead climate technology negotiator at the U.S. Department of State, where he coordinated the engagement of the U.S. in the Intergovernmental Panel on Climate Change. led U.S. negotiations related to science and technology in the UN Framework Convention on Climate Change, and directed the department's effort in the survey. Okay, that was a mouthful. He initially joined STATE in 2011 as a Science and Technology Policy Fellow of the American Association for the Advancement of Science. He has a PhD in atmospheric sciences at the University of Washington in 2010, and he has a BA in chemistry from Colgate University. So thank you, David, for joining us. So if I could get also Ben and Janet to join us in the front. Janet, would you mind joining us? Oh. So I'm going to start the panel by asking just a few questions, maybe reflecting my own background in political science. So I'm very interested in this idea of water security that Ben just introduced, and in particular, how it relates to climate change as we observe it today. We've heard a lot about projections for 2050 and 2100, but what about the situation today? So could you tell me and the audience a little bit about where do we already see water stress that you think is plausibly linked to climate change? What are the areas of the world where this is becoming a serious issue already right now or in the near future?
I think that's one for Ben.
I can do it unless someone else would like to speak. I mean, it's already absolutely a plausible issue, and of course, water scarcity is due both to the climate change and climate change crossed by demographics. So, I mean, I think that the classic place that people discuss a lot is what's been happening, certainly in Syria and the Middle East, right? And so there you have a situation that is robustly predicted and already observed to be undergoing drying, crossed by many, many other factors, including unsustainable management of water resources, but where there is absolutely a discernible climate trend signal that contributes directly to the scarcity. There are other regions as well, parts of Australia, parts of Southern Africa. There are places where the signal is quite clear, but I would certainly say that that's at the top of people's lists. Another place that's interesting is the Horn of Africa. What's interesting about the Horn, I'm thinking of the Eastern Horn, Somalia, semi-arid Kenya, southern Ethiopia, is that climate models actually project they should get wetter under climate change. We've been under a 20 to 30-year drying trend there, and there's a lot of discussion in my world about whether that's going to turn around or not.
Good. Just a little bit on the food side also, there's very good work now done by David Lobel and his colleagues at Stanford that show it's not on the water side, but there's measurable negative impacts of climate change on food production in maize, wheat, and rice. As much as 10 to 15% losses of production already, as of, say, 2005, compared to what it would have been without the climate change that we saw between 1980 and 2005. And that signal is partly through the water, has been the same.
Seems like we've got a nice chronology going here, so I'll go next and kind of zoom in from Ben's sort of global perspective to where I've been focusing the past couple of years more domestically in the U.S. space. And there's a couple things that were highlighted in the National Climate Assessment, which I would be remiss if I didn't highlight to everyone, and that we got hard copies out front. But I think one thing that kind of came through is that, you know, this is not an issue that is isolated to the Southwest in the U.S., right? And I think that's oftentimes what we think of. But, you know, you saw a couple of years ago the city of Toledo really grappling with issues of harmful algal blooms in Lake Erie. You saw it actually dominate a political race in Florida last summer or last fall. Now, multiple stressors are involved in that. One of which may be higher temperatures, but I think that's one thing to keep in mind. The other thing is, and Ben touched on this as well, is the issue of groundwater and groundwater extraction. And this is surprisingly more important in places like the High Plains. You know, you have a lot of untraditional oil and gas extraction going on up there that is putting enormous stress on groundwater reserves that are not being replenished, and so by natural cycles, and so that's a big issue. The other thing, kind of moving east to west in the sense that I'd point out and that we talk a bit about in the National Climate Assessment is when you look at Hawaii and the U.S.-affiliated Pacific Islands, they're obviously vulnerable for a number of reasons. And if you look at in particular, there's a remarkably striking photo of the freshwater reservoirs on Majuro Atoll in the Marshall Islands. And these reservoirs are literally, they collect the freshwater runoff from the runway that then get obviously treated. But there's maybe, tens of yards between those reservoirs and the lagoon on one side and the ocean on the other. And the intrusion and the overwash that can happen from rising sea levels, high tides, king tides, and worst case scenario, an extreme storm, can really, really cause problems for an entire island's water supply, which has lasting effects and very, very costly effects, because once that's contaminated, the ability to get fresh water to those isolated regions is really challenging.
Hi. So just to add a few things, lots of good things have been mentioned, a few newer ideas to throw into the mix that I run into. I work mostly domestically on our water work. We do a lot of work at Food and Water Watch on water infrastructure, which is in terrible shape for a bunch of reasons, mostly due to lack of willingness to invest. And climate change is only making that a tougher situation, right? So every time there's a hurricane, every time there's some, these systems weren't built for that. So the example of, there's just not enough space between the system you need for people's basic function and whatever body of water is going to come flood it. So we're going to spend a lot of money on our infrastructure responding to extreme weather, and we can rebuild it in a more resilient way or not. And we're not really having that conversation because we're just so far behind on the normal maintenance, right? And they're not yet having a sophisticated conversation with infrastructure really anywhere, but especially in the U.S. about like what you need to do to be ready for a increasingly chaotic climate. In the world of food, I talk a lot to U.S. farmers, and it depends what radio they listen to, whether you're going to talk about climate change or whether you're going to talk about extreme weather, but they all agree it is not normal, and that you will hear there is no normal anymore for me as a farmer. That is now accepted, but what they're getting in response is pretty erratic, and most of it's not anywhere near the scale of what we need to deal with this problem, right? So we're not talking about any kind of changes to our farm policy that break us out of a really, resource-intensive, water-intensive monoculture commodity crop system to be more localized, more resilient, more focused on soil health. We're getting little dribs and drabs about maybe we should do some cover crops once in a while and we'll pay you to do that, and maybe we can tweak our crop insurance, but we're not sure yet. So the realization that it's not going to be normal again, I think, is setting in, but the responses that people are seeing are not. And then the last thing I'll say is because Food and Water Watch was dragged many years ago, not through our doing, but because we work on water, we were really dragged into the fight over fossil fuel extraction in this country, particularly fracking. And we're seeing increasing conflict between energy infrastructure, especially fossil fuel infrastructure, and our food system. And it happens in many layers, right? We don't like this fossil fuel extraction because it's going to drive climate change, but we're seeing competition for water in places between agriculture and fracking companies, who is going to get that water in a market situation. And when you have a drought in California and you've invested in a food system that is super water intensive and occasionally is a perennial like almond trees, you're not going to let those trees die. You're going to do what it takes to get water for them. And if that means recycling produced water from oil wells that we're not super clear it's a great idea to use on food, you're going to do that anyway because we've invested and we've put everybody's incentives into systems that don't think about water as they make those calculations, right? So we're just not, people are seeing the wheels start to come off, but we're not presenting folks in the food system, I don't think, with the kind of level of solutions that we need to be thinking about.
Janet, anything to add?
Well, I mean, sort of ditto and ditto. I mean, in terms of the food security challenge, which I think is just an overwhelming challenge as it is. I mean, climate change and its impact, either directly or indirectly through water, it's already making things. It's not a future thing anymore. It's already making things a whole lot more difficult. And I just sort of like despair at the limitations of our governance systems to be able to take sort of more joined up, holistic, long-term thinking approaches to it. I just sort of like responsibilities, the drivers and the solutions are just scattered across multiple agencies that just don't seem to be able to get their act together and coordinate and consult. So you have agencies almost sort of pitting other, their goals against the goals of other ones. So I despair. Yep. And I mean, I present some of these demand side solutions. I mean, that I talked about as sort of issues related to water security. People don't think about food waste or what are they ordering on the menu today as issues related to water, but they very much are. And there are things that individuals can do. They can't maybe change too much about whether they're farmers, sucking the aquifer dry, but they can make those choices.
Wonderful. So on that optimistic note, I wanted to maybe ask the three new panelists who haven't given keynotes yet, each to just take a few minutes to reflect on what might be some possible solutions to this problem. So what is it that the United States, maybe under a somewhat different political configuration in the White House, what could other countries, what can international organizations do to solve these problems? What are the key solutions that we are looking at that could really make a difference here? And I really encourage each of you to take whatever perspective, level, or region that is most interesting and exciting for you. So maybe, Mark, could you just give us a few comments on that?
Thanks, yeah, and I'll be talking from the perspective of developing countries primarily, though some of the things I'll talk about also apply to, of course, to a developed world context. But I think one of the surprising things is bigger crises as we see on water and food security is that despite all the pressures and water scarcity, water is managed really poorly. And in a lot of cases in developing world, one of the big problems is that farmers don't have secure water rights. So they don't have the right over their water to make the decision. So let's say they invest in an improved technology. If that changes the water flows and distribution within the system, they could end up losing their water because of it. So there's not strong enough incentives for them to invest in on-farm technology improvements and management improvements. So to me, almost the key thing in the developing world is to move towards much stronger water rights for farmers. And it's not an easy thing to do. There's been some success in some areas, but there has to be a lot more, and it has to also protect women in particular who tend to lose out in formal empowerment processes. But it also has to allow them to be able to make decisions for water that improve the water situation and produce more food. Somewhat related to that is that despite the scarcity, water and energy to pump water is given away almost free in much of the world. It was basically political reasons and cultural reasons as well, and maybe for decades that was acceptable. And now it just makes it again impossible to get the proper incentives in place for farmers to manage water correctly. And a lot of those incentives subsidies meant to benefit farmers actually benefit, for example, fertilizer or energy companies, not farmers. So there really has to be a movement away from those high generalized subsidies. In India, for example, about 5 times as much money is spent annually on water and energy subsidies is spent on agriculture and water research. So you can actually generate huge budgetary savings by reducing those subsidies and reinvesting them, and I would say in 3 areas: in agriculture research and development, in some targeted compensatory income for farmers. So some farmers will lose. For those now with the high-tech IT and so forth that we have, you can, and mobile phones, you can target who needs the additional income because they lost subsidies. And the third area then would be to hit targeted subsidies. So instead of, in general, subsidizing energy, water, and fertilizer, find specific promising technologies where early on subsidies targeted to the smaller farmers can initiate processes of adoption and scaling up. In terms of what you would use that agriculture research and development for, funding for, there has to be much more targeting of productivity of plants with respect to water and land, and also to target the climate change threats such as increased stresses like pesticides, like pests and disease. And those aren't easy. Those are going to take a lot of strong work. maybe just mention a couple other things. Janet brought up the really important need to save food and water in the value chains. And so there has to really be a much better investment in bringing together public and private partnerships in developing worlds to invest in things like rural roads, cold chains, water recycling and reuse to reduce those post-harvest losses of food and water and to increase farmer income. There's significant potential of things like blended finance, where the government would help guarantee some of the funding from private sector to move forward. But it's been hard to get those things in place. It's really time to move that way. In addition, there's, again, to try to harvest more advanced technologies such as satellite-based remote sensing and ground sensors as well to map groundwater, measure water available and use, together with integrated information processing to try to, again, get real-time water and crop decisions made more effectively. I could stop there. I think I talked too much longer, so I'll let it go further.
Wonderful. Thank you very much. David.
Sure. I'll kind of, again, zoom back in a little bit to the national scale. And looking at the water side of the equation first, or maybe just kind of both of them first, we have a growing collection of tools at our disposal, both domestically and abroad. I don't know if Ben mentioned the FuseNet, which is the Famine Early Warning System network, that really helps identify, potential hotspots of food insecurity, and actually does help inform agencies like USAID as to where to target increased aid, which can sort of, in some cases, hopefully stem off potential conflict or instability. We also domestically have NIDIS, the National Integrated Drought Information System, which certainly helps, again, provide some early warnings. So I think better education and use and capacity building in particular abroad to use some of these tools and to expand their reach and coverage is one first step. From more the kind of targeted towards the water and then the food, I think the biggest thing for water, I would say, in a lot of ways is conservation. And it's a pretty standard thing that's a pretty big bucket, though. And we have a lot of good success stories domestically already. You look at some places out west in Los Angeles, for example, I think their water consumption has been pretty steady for 45 years, despite the fact that they've increased population by 1 million people. Similarly, in San Francisco, they've decreased their per capita consumption by something like 25%. But the challenge here is that even though per capita consumption may be decreasing in certain places, population is increasing, and so
The Central Valley.
right, yes, there's that component too. And then the conservation comes with banning wasteful practices, right? Should you really have Kentucky bluegrass in, New Mexico, or should you have native species? I think that's a reasonable thing to think about. Hosing sidewalks every day when I come to work. There are things on the sidewalk that I might not want to see, but is that the best use of water, even if it is gray water? Desalination. There's a huge, there are all sorts of issues around desalination. The brine waste, the energy intensity of it. We have something like 650 desalination plants in the U.S. alone right now, which was kind of a surprising stat to me. And for those that are interested, OSTP just recently released, about a month ago, kind of a coordinated strategic plan for desalination domestically in the context of water security. Two other things that tie into the food piece are drip irrigation and watershed protection. I think both of those, obviously, you look at drip irrigation, I didn't realize just how important something like that could be as opposed to center pivot or stepping out of my realm a little bit here, but enormously beneficial in terms of saving water. As far from the food perspective goes, there are adaptation measures about altering your management practices, right? And some of this is the timing of your planting, making sure that you're aware of some of the drivers of changes to that timing. Some of it is, some of the tilling practices. One of the things we highlight in the Midwest chapter, for example, is the incorporation of prairie strips into fields, which can sort of minimize or reduce soil loss. And then there's the loaded issue of new technologies in the agricultural space about drought and salt tolerant crop seed varieties and things like that. So there are, a lot of options before us. We in the U.S. are very fortunate in a lot of ways because we have a lot of resources to address these issues compared to a lot of developing countries. But, as has been raised, there certainly have been instances where we are not taking full advantage of all that we have to offer here domestically.
Wonderful. Patty.
So just a couple of things to add, and this is just because this is what my last couple of weeks have been like. I mean, agriculture and the U.S. farm world is having this conversation, right? But I think I'm just struck lately about how we're missing some parts of that conversation. So I think, there are still folks who don't want to talk about it's climate change, it's man-made, whatever. That pool of people, even in rural America, I think is shifting. It's shrinking. Other folks are like, okay, fine, it's happening. What are we going to do about it? So there is a pool of people in the food system who do want to be part of the solution, and they are increasingly not seeing themselves in some of these discussions. And I think that is a caution that we need to keep in mind. And the concept, so lots of folks have been very excited this year, especially younger folks, about the prospect of a Green New Deal. And it's not because of what's on the paper of a Green New Deal, because it doesn't exist yet. It's an idea, it's a discussion, right? It's like a couple pages. But what seized people with excitement, I think, was the concept of climate change is this big of a problem. We're going to need an equally big solution. It is going to be a transformed economy in a lot of ways. It's going to be a different energy sector, a different transportation sector, and it didn't really get there on food, and we're talking to them. It should have a different food system, too. So there's a lot of potential there, but I think the most important part of that we've gotten a little better about talking to people about in the energy side of things is the concept of transition and the concept of a just transition, that people have to see themselves in these solutions or they are going to fight it, right? So still hasn't worked yet in West Virginia, but people are getting a little better at talking to people who work in industries that are going to either disappear or radically change, either just because we have a changed climate or because we need to change that industry to stop climate change, right? We need to have a conversation in Appalachia about what it looks like if you're not a coal miner anymore. We need to have that conversation in farming too, and it currently isn't happening. And if we don't, I'm very nervous about what the pushback is. And because this is a political problem, right? We are going to solve some of these things or not solve them in the political arena. And how we have this conversation with people who see themselves in the food system could really determine what happens. And I think we're behind on that collectively. So there's lots and lots of nuance about how people see themselves producing food that get lost in very high level. We have 15 minutes is obviously not everything, but people want to talk about, well, the way I raise animals is different, and they're on a pasture, and I'm putting carbon back in the ground because those are perennial roots. I'm not tearing it up every year. I don't put the manure from my animals in a lagoon where it breaks down and generates methane. We're having a lot of conversations about shit, literally, as we talk about climate change and what kind of shit and how we manage it, right? And that's part of this discussion, and that could be part of a transition, right? And that's a different land use, and it's less corn. But we're not going to replace all those animals one-to-one with pasture-based animals. There's going to be less meat in a system where you raise animals that way, right? So these are big picture conversations, and right now some people are kind of intrigued by that and excited about it, but a lot of people are afraid of it because they don't see a place for their often family business in that conversation. So I think that's something at all levels, right? I think internationally as well, but particularly domestically, we have to get better at pretty quickly to avoid a lot more wasted time, in the political arena where people just fight everything.
Janet and Ben, do you want to add something on the solutions?
Well, I don't think it's a lack of solutions that's a problem. I mean, all of us have got our solutions. I put up 22 of them, in fact. The problem is that there isn't the political will to do what's necessary to implement them. So what are we going to do about that? I mean, there's vested interests. There's the fragmentation of the governance structure. That's what we really know. It's not the what or the why anymore, in my view. It's the how, and how do we drive these solutions at scale so they're not just sort of boutique things. All those 22 options I put up there, every one of those I can point to places where they've been implemented successfully. Now, of course, they're not going to be relevant to every place, but there isn't a political will to scale them. And the reason I'm getting interested in data and all of that stuff is because I've got to create the political will. I've got to empower people with data. I've got to show how, I've got to connect the dots across these agencies, connect this data to people's lives so they understand it, so that I can drive that will, because I don't know how else to get it. I don't have the lobbying money that's required to beat some of the vested interests that are preventing us from implementing some of these solutions right now.
Ben, do you want to add?
Well, yeah, just briefly, I think there's a lot of room for hope in just how bad we are at things right now, right? I mean, it should be pretty easy to improve some of these things if we actually get the will. And just to build on Janet's point, one thing I've become very interested in recently, and I think it applies to this context, is that disconnect between the optimal solution. You can think about this in terms of deep decarbonization or think about food system transitions. The way we think about doing that, the way we lay it out kind of top down, and the actual kind of political ecology of making that change happen. And the lack, there are people doing good work on both sides of that, perhaps the lack of recognizing that you have to have that bottom-up perspective guide that long-term vision. And that right now, I think we provide a lot of long-term vision with like integrated assessment models and things like this that show, oh, you can solve this problem. But in fact, you can't get there from here. And what you need to do is start from the bottom up and understand how each step along the way changes the will for the next step. And my understanding is that we don't have that framework in a lot of sectors.
Excellent. I don't want to stand between the audience and the wine and cheese, so I'm going to move right into Q&A. The Q&A is going to stand between the audience and wine and cheese, but I'd love to hear any questions, comments, thoughts from the audience. So, we start from the back. Yes, Will, please.
Hi, thank you guys for all coming in and speaking with us. It was a very interesting talk. I have a couple of different questions, and so I won't ask all of them now. I'll let others speak, but I think one of the panelists mentioned FuseNet. And I find that to be an interesting platform, but I don't think it's enough. I remember I was doing research on sort of 4 developing famines in 2015, 2016, and we saw them using FuseNet. They were in northeast Nigeria, Sudan, Somalia, and Yemen. But they happened. People saw them coming, but still there was really not enough action. So I'm wondering, what can we do when we know famines are going to happen? How can we actually act? And then second point on that is FuseNet, in my experience, it can't see certain types of crises. So the fall armyworm sort of has been decimating Africa for a couple of years now, but it's like a slow-moving crisis. It's not immediate like a flood. So I'm sort of wondering, how can we change the way that we see food crises?
I can just speak a little bit about, I'm aware of FuseNet. I'm also aware that the technology is really significantly advanced. So there is proprietary technology out there now that actually measures crop yield in situ, in the field, in real time. They've developed a satellite method which measures the chlorophyll pigment. So it's possible at the sort of very high resolution now at the farm or sub-farm level to look at yields as crops as they're growing. And that's been done for several of the very lucrative commodities in the United States. Unfortunately, that data is not in the public domain. But the technology is there. We can do this. If we had training data, we could produce a system that's actually monitoring, very high spatial resolution crop yields. So if we had that information, like just say we had that information in Ethiopia, we could actually compare what yields are there to what the potential could be in that country. Is that going to help us sort of target it? We could overlay that with information on water risks so that when we do invest in yield improvements, we're not investing in crops, irrigated crops, to be planted in deserts where, there isn't going to be this. We could actually look at the improvements of investments in there. That technology that I talked about was developed by this organization called Descartes Lab. They were going to sell that data to hedge fund managers and insurance companies, and now Cargill has bought the methodology for themselves. We can do this. With small research grants, we could produce this monitoring methodology and have it as an open system in the public domain. Just think what we could do with that.
There's a similar debate here in the US just on seed technology and getting back to some kind of equivalent of open source, right? We used to have publicly available seeds that public land-grant institutions developed. And we have them, but they're shrinking, right? And so I lobby with organic farmers, and we ask for this every time. People want regionally adapted seeds that don't have the patents on them, and that's here, let alone developing countries.
One other thing I'll just say in response is that I think both Janet and Ben touched on it in their presentations, is that it's not necessarily a technological limitation, but interinstitutional communication is actually a really huge part of this and a huge challenge. And especially, I think it was Ben that showed that slide about the forecast-based things. And when you're trying to do something, droughts can be, they can be prolonged, but there can be other instances, like a heavy precip event that, where the response needs to be far, far quicker, and you don't necessarily have as much lead time to mobilize the resources, especially before the event actually hits. And so I think interinstitutional communication is a huge challenge to overcome.
Sorry, let me start. Just to the FuseNet point specifically, because we work with them on this. What David just said applies directly to FuseNet. We have institutions that explicitly do not use the forecasts. So USAID is helping coordinate this, and there are elements of USAID food aid that will not use the forecast. And this is true in many institutions around the world. And so the examples you listed weren't the first, right, where FuseNet called something 6 months in advance and nothing was done. And so I think that that's absolutely critical. And I just also want to thank you for mentioning pests, which we failed to mention explicitly. In the forecast sense and in the projection sense, right? Like most of those food projections for climate change don't have pests. And so I think it's critical.
Hey there. Thank you all very much for very interesting and insightful and diverse perspectives on both problems and solutions. Quick observation, just over the past 48 hours, I've seen Greta Thunberg speak in an incredibly impassioned way before EU leaders and then meet the Pope this morning. And so one observation is just there's a level of urgency that I'm seeing in the youth today that's incredibly inspiring. And I think Bill McKibben has been saying a lot of the same things for 30 to 40 years. But there's a timing aspect, and I think that's one thing that I do feel very optimistic about. My second, I have a question, I guess, for Janet. One of the demand reduction solutions that you had up there, a bullet, was around fertility rates. And I'll posit something maybe a bit heretical, but I'm not sure that any of this really works with 10 billion people on the planet. And so I think it would be interesting to include, the demographer perspective around, we could make our lives a lot easier by kind of figuring out solutions to keep the human and livestock biomass at more reasonable volumes. So I don't know if anyone has any comments on that.
Thank you for that vote.
And I know we have a bioethicist sitting right in front of me.
Of kind of optimism. I think in our business, one cannot be a pessimist. So I'm glad to hear that optimism. I do sort of feel that there's a sense that, there was a big debate at the World Economic Forum. Is it a climate crisis? Is it a biodiversity crisis? Is it a water crisis, a food crisis? And the fact of the matter is, it's all of those. It's a planetary crisis. I don't even want to fight with my colleagues about whether this issue is important. Then they're all interlinked. I mean, I know they're interlinked. I can talk about how they are. So I'm glad I get my energy. I have two young girls. I mean, two youngish girls, but I get my energy from the youth now. It's great that you met Greta. She's fantastic. I mean, the schools are students are starting to march. It's like, I've been waiting for this outrage. I mean, like, you see all this stuff. This is your future. Why aren't you marching on the streets? Now, where's that outrage gone? It's like, people read this stuff and then they turn the page and they eat their donut, and I don't know. But anyway, I'm seeing signs that it's coming back. We need that. I mean, I'm really interested in data and visualization because I think we can communicate the problem more effectively in ways that connect to people, that they understand. What was your other thing, the point of?
Demographics.
Oh, right, yeah. So we put that in there, yeah, because it is a part of the solution. But, the good news is that most regions now are reaching replacement fertility levels, which is about 2.1, 2.2. The exception now is sub-Saharan Africa and parts of southern Asia. And the fact of the matter is we know exactly, we've known, because we've done this really well in most areas now, we know exactly what we need to do to bring those fertility levels. They will reach replacement level. We need to get them there sooner. Otherwise, we're going to have this population bomb. We need to do two things. We need to keep girls in school. We need to have them into primary school, and we need to keep them there. We should be doing that anyway, even without all of these other crises. And the second thing is we need to provide access to reproductive health care services. Those are it. Those are the two things we should be doing anyway. It's not a complicated problem to solve. Again, we need the political will, and we need the support to do this.
Okay, so Janet had presented a bit on the diet space and reducing high environmental footprint type diets, so beef being one. Just to get a read of the panel, how do you all feel about these future foods? You know, the lab-grown meats, the finless foods, which are fish grown from stem cells. And how do you feel in the sense of, from a livelihood perspective? So maybe Patty on the livelihoods of farmers that are cattle ranchers in the United States. From the water perspective, from the health perspective, and most importantly, from the demand perspective, do you think there is a future for these future foods?
Let me start. So you've been looking at the other conversation that's been dominating the last 2 months of my life. Right in this particular moment, we're not in love with the way these things are being rolled out. Like, this is a very fairly testosterone-driven Silicon Valley approach to disrupting a thing that people put in their bodies, not just on their computers, right? So I'm going to need you to get down with the FDA regulations and do the process to make sure that it's safe to eat, which we're not seeing so much. So when I take my little consumer advocate hat off after that little speech, because we need to have some regulations before I eat this. Setting that aside, we need accurate non-proprietary model-based footprints to actually, if you scale this out, what are we talking about for energy? I mean, we're fermenting things in vats with a lot of water with some kind of feedstock, and I'm going to need to see some models that include all of that, because that feedstock could be soy, it could be corn, it could be methane, right? You can feed these little buggers lots of things to make the oil you turn into the fake cheese. So right now it's pretty small scale, and we're getting a lot of very proprietary, very sales pitch level data about how it's the fix. So we need to have a real conversation about those metrics, and they need to use the same metrics. They're currently not. Having said that, in the US, we eat an enormous amount, more than we need, of animal products that are raised in a way that is crazy in terms of our resources. So our system is going to look, animal foods are going to look a hell of a lot different in a system that is either dramatically transformed because climate got crazy or because we tried to head off climate change and change our food system. There's going to be a different role for animal products, and it's probably going to be a much, much less role. Whether people need their veggie burger to bleed, I don't know. But we are going to have to change our relationship with animal products. But there is a great debate, and we're really, really good, and we're trained as consumers, not as citizens, to be as reductivist as possible when it comes to food, right? And so part of why I'm like this is because most debates about food right now are, do you have to be a vegan or should you eat only bacon, right? We have nothing in between. This is how food choices are presented to consumers and to us as citizens. We're not supposed to vote about food. We're just supposed to pick a diet, right, and fight about it. So we're missing a lot of this nuance. There's going to be some plant-based stuff in there so we can ease up on the intensified animal production, which I think has a different footprint than pasture-based animal production, but I don't know if I'm ready to say these particular products are the only way forward.
Could I put a little twist on it? And just in defense of meat, not in the United States, but in most of Africa and much of Asia, people need to eat more meat, not less meat. You're talking about people who eat maybe 1 kilogram per year, and the best way and they suffer micronutrient and protein deficiencies. The best way to improve those deficiencies is to get higher levels of meat in their diets, and preferably, as you said, to do it through more pasture and other systems. So that, here in this country, we're all focused on, wow, we eat way too much, but in much of the world, more meat is a good thing.
I can speak a little bit. I'll just sort of really clarify that we have never said in any of our recommendations that no meat. We have specifically focused on less meat, especially ruminant meat, in those countries that consume a high amount of that. In part, to create the planetary space to allow those countries that don't eat very much to be able to eat more. In fact, the average male American, for example, consumes twice as much protein as he requires by his, the WHO recommended guidelines. So we're all getting quite a lot of protein in this country. In the United States, beef consumption has fallen 30% since 1970. And I hope we haven't lost our farmers in that process. Yeah. So, I mean, I'm assuming that there will be a reduction in beef consumption by those high, but I still think there's going to be a demand for beef, especially when it's sustainably produced, high productivities on land. As for the fake meat, I haven't tried it yet. Well, actually, I did try it by mistake once, and I didn't like it because it was so real. So maybe that's a good thing. It is going mainstream, though. I mean, Burger King has now, got it is testing it out in St. Louis, the Miracle Whopper, as they've called it. So I'm watching that quite carefully, but that might make it easier for some people to eat a little bit less,
So I just have a quick question if any of you'd like to comment on sort of what's the overlay of urbanization with all of these topics that we're talking about today, which is a very broad and very huge question. So you might want to break it up. This has just come to my mind because, there was this big report on agricultural employment declining and people in this country not going into agriculture anymore, which has a lot of sort of knock-on repercussions about knowledge about your land and who then takes over that agriculture, whereas that conversation is not the same conversation you would have in sub-Saharan Africa or India. But I think urbanization's big for all of those uses of food as well as water.
I can have a go. So one thing that happens when people move to cities, as they are increasingly across the whole planet, one of the first things that happens is their income generally rises. Well, it's changing. You're absolutely right. In Africa, there's this stagnation problem, but actually in emerging economies, that was the case. So yes, I agree with that. So as their income went up, then they consumed higher in the food chain, they eat more consumption. So some of the numbers we have about average meat consumption for countries really mask this huge difference between rural and urban areas. So there is that issue. But there's also the issue, if the people are moving out of the rural areas, what's left behind there, and is that where governments are now going to invest in all of the cities? Where's the investment for the rural areas? So I am really kind of concerned about that. And I think there should be a compact between cities and rural areas, because, cities, they can't get all this cheap stuff that they barely pay anything from rural areas. There has to be a compact, and it's not just food. I mean, it's like, how you manage your farm. You're providing a ton of other ecosystem services for free that cities depend on, whether it's Watershed or, you've got trees on your property. But I think there has to be a more fairer compact between the urban and the rural area, because it doesn't seem to be working. It doesn't seem very fair to me.
One of the other things I'll say is that urbanization comes with usually more exposure to water-related threats. I don't know this for sure, but I would wager to say that the majority of cities in the world are either in coastal areas or on rivers, right? And so you largely expose yourself to additional climate-related threats. And when you compound that with urbanization in the sense of, okay, you got more people coming in, you're almost certainly going to create more impervious surfaces, which exacerbates flood risk and all the issues that come along with that. Now, at the same time, if you have more people in a concentrated area, one could argue that there's an opportunity for efficiency gains, right? And so I think that's something that could be explored. And you're seeing it, in places like China oftentimes where, we talk about retrofitting a single building here, and they talk about retrofitting, or not even retrofitting, but basically designing, city blocks, if not city neighborhoods at efficient scale. So I think there is, I hesitate to say this, but I think there's an opportunity in the urbanization aspect, recognizing that, of course, that there are new vulnerabilities and exposures that get created in the process.
So,
Did you have any thoughts?
so why don't we take one more question? I think. Oh yes, of course.
We talked about a lot of things tonight. So I was curious, because with climate change, there's many different level of urgencies, but we haven't really talked about climate refugees, because the rise of the sea level urges some of the islands to look at other places to go, and there's also smart agriculture. So what do you think states should do to prevent that? Because it's a crisis, but then there's ways to prevent this sense of urgency.
Well, I mean, we've done some work on climate change effects in the Pacific Islands, and there, to some extent, some of those islands they're just going to have to relocate their populations. They're already in processes of negotiations with New Zealand and other groups, and trying to put together funding packages and relocation packages, and there's really nothing. I mean, the amount of money it would cost to protect those is infinitely more than you could afford. So those are some tragic situations. Now, others of those islands, there is things that could do to delay the inevitable, but it'll take a while. The climate refugees, probably others should speak to that more. I mean, to me, it's rarely the climate or the specific weather event that is the telling force. It's sometimes something that sharpens some things that are going on for fundamental political and reasons. So I'm not as sold on climate refugees is a huge thing, but maybe others disagree with that. So.
I mean, it's always you're absolutely right. It's always multiple variables. I mean, it's sort of climate refugees linked to bad agricultural policies, growing crops that need to be irrigated in deserts, not having sort of social safeguards in place. I mean, it's we have to sort of connect the dots on it. But like I said, climate change. It's a threat multiplier. It takes all the other problems and exacerbates them. So it's going to be. That's why you can look at two areas, okay, and they might be exposed to the same climate change, but they might fare very differently on what sort of social protection and governance that you kind of got in place. I mean, look at California; it survived that crisis, whereas we've had. Yeah, you might be right. It hasn't. Depends how long you look at it. But I mean, yeah, we shouldn't be watering the desert, in my view, but that's another matter. But it's multiple factors. And the good news in there is that there's things that we can control. I mean, there's things that we can do. We might not be able to turn the climate change off anymore. Then we are lucky if we get to 2 degrees. If we're really lucky, 1.5 degrees. But there are lots of things that we can do to help reduce the suffering that's going to come with it. But we have to be ready. And we have to make the right investments. We have to make smart investments. And we have to stop creating the problem. We have to stop contributing to the problem as well.
If I could just say, there's an issue, and it was touched on, the difference between displacement and relocation, right? I mean, you look at something like Katrina and what that did to the population of New Orleans, and then you look at something like Harvey and what that did to the population of Houston, and you compare that to, Newtok in Alaska or the Ile-de-Jean Charles community in the Mississippi River Delta region. Very different issues, very different resources at their disposal. And Ile-de-Jean Charles, for example, they are working with HUD, with the Department of Housing and Urban Development, to receive grants to physically relocate their community. And you're seeing that happen in a lot of these vulnerable coastal communities domestically, where, I think one of the most important things is that you have a participatory process with the community to understand what the people want and what the options are. And, there's a really kind of fascinating kind of I think, sociological, anthropological look to be done at what happened post-Harvey in Houston, because, you know, the city, if I recall it correctly, initially agreed to change some of the zoning laws and to change some of the standards and how they build. And they ultimately got overturned, right? And so, you know, there's this issue of trying to overcome, you know, the historic momentum and inertia and the drivers for kind of, frankly, maintaining your near-term tax base versus an actual sustainable community for over multi-decadal timescales. And you see that playing out, you know, frankly, almost in real time with the National Flood Insurance Program.
So I think we had one more question in the back. So if you don't mind keeping it brief, we'll then take one more round.
Very brief. So one perspective that I don't often see in these discussions is the national security perspective, and I think the panel touched on it briefly about the connection between food insecurity and regional instability. And so I was wondering if you guys in your work have any sort of, if you work with people in defense or intelligence and how they think about these issues, and if there's any potential for partnerships in the future.
I can just speak from the federal government perspective. Yes, absolutely. I mean, I think you can look at the World Threat Assessment that came out from the intelligence community, you know, a few months ago, and you see it fairly front and center. And I think it was Janet that talked about climate change as a threat multiplier. It exacerbates existing risks and existing sources of instability, whether it be, you know, a history of civil violence, lack of economic opportunity, poverty, weak governance. All those things kind of map onto that. And there's certainly a recognition in the national security infrastructure of the U.S., both from the intelligence side and from the defense side. We touch on it in the National Climate Assessment, Chapter 16, the climate effects of U.S. international interests. It's a new chapter this time around. And one of the things we look at is kind of the multifold aspects. One is kind of the obvious things like military infrastructure around the world, right? You look at Norfolk, you know, as one obvious example. But also, what does it mean for humanitarian response and disaster assistance, right? And there are multiple lenses to this, and we touched on it a little bit in the last question with kind of the displacement and relocation issue. So yes, I think you can see, if you just read the news, you saw, you know, spanning administrations for multiple administrations. Now you see defense and intelligence communities, you know, saying this is a real issue, and it's something that we need to pay attention to it and make investments accordingly.
I'll just sort of, I mean, I'm British, as you might have guessed, and, you know, the flood of migrants into Europe and from across the sea to the UK has had and it's not all about climate change or food insecurity. There's all sorts of variables in there, but if you sort of delve deep down into the roots of some of these things, I mean, the drought, the prolonged drought, the spike in food prices, you know, people abandoning land because the crops had failed, they're moving to cities, the ethnic conflict that happened there because there isn't much room there, and how the government responded, it did, you know, contribute to this massive flood of migrants into Europe, many that came also to UK. And it's a big crisis, and I would argue that what we saw there was just the drip, drip, drip of what potentially could be a massive flow from many countries simultaneously at the same time. And I look at how that crisis has sort of almost rearranged the nature of politics in, you know, Brexit in part. My mother voted for Brexit. I can't believe it, but she did, you know, in large part. There's this fear of all these people flooding across the border. It was definitely a factor in it, and politics have changed now. We've got more nationalistic governments. And that, with what I think was just a small drip, drip of what we can expect to see in the future. So this really keeps me awake at night. And some colleagues of mine went up to the UN Security Council in November with data, you know, and tried to sort of make the case that, you know, this really needs to be an issue that's on the security agenda. But it's still the more traditional weapons and armies, and but I think this is more of a security crisis than anything. What are we going to do? How tall will we build a wall to keep people out when they're starving and hungry and displaced? What's it going to take?
Excellent. That's,
On that
we can
nice
always
note.
count on Janet ending
Prevention
with
is worth 10
with
pounds
with
of
a positive
cure.
note. That's wonderful. This has been great. I learned a new word, finless food. That's fantastic. I learned so much about water, energy, food. It's clearly a very complicated issue, and we've had a great panel here sharing their latest insights based on cutting-edge research and some activism as well. So please join me in thanking our panel for this wonderful discussion.